Pardon me, begin. So I want to touch upon two little things for the homework. Don't mind the little sound that you hear in the background. So we're going to talk about solving linear inequalities. Okay. So solving linear inequalities is very much the same thing as it's similar to solving equations. So let me give you an example. So if I have this inequality, 3x minus 4 is less than 2x minus 1. The idea is I still want to isolate x. So I want to put all the x's on one side of the equation. Hold on, let me see if I can stop that music, that sound. Hold on. Okay, sorry about that. Oh, whoops, so goes. Uh, Sorry about that sound there that you hear. Um, will the quiz pretty much be based? Yeah. It's simply, well, actually, the quiz is everything we talked about until last class. So everything that we talk about today will not be on the quiz. So everything that we talked up until last class, and I delineated for you the topics on the email. How many questions? Well, in the email it says 5 because there's 5 topics. And I mentioned to you guys the 5 topics on the email. So everything that uh, we've done so far. So for example, solving first degree equations and finding sets of intersections and unions of sets, graphing them, operations on rational numbers, and classification of numbers, knowing what's a rational number, what's a integer, like knowing that difference. Those are the questions that you'll see. Yes, Jalen, you only need the Google Classroom for the quiz. You don't need anything else. So as long as you're on Google Classroom, you will be able to see the quiz. It's going to be an assignment, and then you could be able to upload your work. And you have 15 minutes, Sherelle. That's the idea, 15 minutes. It should be short. It shouldn't take too long. It's not a test. It's not like a full-fledged exam. And it's no, you upload it onto Google Classroom. I hope everyone understands that the quiz will appear on Google Classroom as an assignment. And what you're expected to do is, as the assignment is given, right, to upload the work that you have into the assignment on Google Classroom. So you're gonna be, when you open the assignment, it's gonna give you the option to add a file. And the idea is that you take pictures using your phone. I hope everyone has a phone that you can take pictures with, in which you can create a PDF file, and that PDF file upload it onto Google Classroom. So part of this whole pandemic, social learning, distance learning, is having to deal with technology. So that's part of the whole package, right? Okay. All right. So solving a problem like this, I want to get all the x's on one side of the equation and move everything that's not an x on the other side of the, well, this in this example, it's not an equation, it's an inequality. So I got all the x's, right? I got two x's on the one side of the inequality and one on the right side of the inequality. So it would make a little bit sense to make them all on the same side, right? So I get x minus 4 is less than negative 1. So I move the 2x from the right side to the left side. And then I want to get rid of the positive 4. So I add the positive 4. And I get that x is less than 3. So this is my solution. I got it. Now I can graph the solution. That's one thing I could do. And when I graph my solution, what am I saying? I'm saying that x is smaller than 3, strictly less than 3. So that means that I'm going to put an open circle around 3, and I'm going to shade everything to the left of 3. So that's one way to express my solution graphically. I can also express solution. My solution, I'm going to express it in interval notation. That's another common way. So what would be the interval notation? So if I shaded everything to the left of 3, how would I express that as an interval? Negative infinity, that's right, Valentine, negative infinity. So I'm shading all the way to the left, which means this is negative infinity. So the left endpoint would be negative infinity, comma. And then what would be the rightmost endpoint of this interval shaded region? It would be 3. And I would have a open circle. And that's it, open parentheses. And that would be the solution in interval notation. Pretty straightforward. That's how we solve this kind of system, this kind of linear inequality. Now, let me give you another kind. What if I give you something like this? What if I give you 2 minus 5x greater than 7? Now, how do I solve this? Yeah, Jalen, we're doing that right now, flipping the sign. So if I want to solve for x, I have to subtract by 2, correct? I want to get x by itself. I want to solve for x. That's one thing I want to do. So then I get negative 5x is greater than positive 5. Then, guys, when I divide by a negative number, so note, when dividing or multiplying by a negative number, switch or flip the inequality sign. So in this case, when I divide by negative 5, divide both sides by negative 5. When I do so, these negative 5s here are canceled out. I got a x on the left side. And then I have to switch the inequality symbol, and this becomes x is less than negative 1. It's timed, Kailani, by me, yes. And David, I will try to give you a practice of multiplying fractions. Um, that's definitely going to be something knowing that you need to know how to do. So x is less than -1. So then what would be the graph of this? The graph would be -1, open circle to the left. And then what would be the interval notation? It would be -∞ to -1, open circle. Okay? Does that make sense? Is that straightforward enough? Okay, good. What if I get something like this? 3x plus 1 is less than or equal to 7x minus 15. So I want to get x by itself again, right? So I can subtract both sides by 7x if I want to put all the x's on the left side. I get -4x plus 1 is less than or equal to -15. Subtract by 1 on both sides. And I get -4x is less than or equal to -16. And I'm going to divide by a negative number. So when I do that, remember what I have to do. I have to switch the sign of the inequality symbol. So this becomes greater than or equal to +4. So then when I graph this, Jalen, that's a great question. And the beauty behind mathematics is if you do it the other way, you still get the same answer. It's just that it will be visually, you would look at it a little differently. And now, and I'll show you. I'll show you how it's the same. So when you graph this, x is greater than or equal to 4, which means that I also include 4. So this here, less than or equal to symbol, it marks inclusion, implies inclusion, equals, right? So 4 also is part of the solution set. So therefore, I have to do this visually by representing it as a closed circle, and I shade everything to the right. And so then when I write this in interval notation, the interval notation is 4 comma infinity. Okay. And now to your question, Jalen, we have 3x plus 1 less than or equal to 7x minus 15. And you say, hey, I don't want to move all the x's to the left side. I want to move it to the right side. So if I subtract -3x, and this is what I get 1 is less than or equal to 4x minus 15, but I still have to get x by itself. So I still have to do this. Move everything to the left. That's not an x. Then I'm going to divide by 4, correct? And then the result is 16. No, the result is 4 is less than or equal to x. But my original solution was x is greater than or equal to 4. Do you see how these two statements are exactly the same? If I say x is greater than or equal to 4, it's equivalent to say 4 is less than or equal to x. Literally, if you reflect this, if you reflect this statement around, you get this exact statement. If you take this statement and you reflect it the other way, you get this statement. Do you see how they're the same? So yes, this is the same. So it doesn't matter if you move everything to the left or move everything to the right. At the end, you get the same thing. It's just that we read from left to right, as someone mentioned before, right? So because we read from left to right, it's more conventional and natural for you to say x is less than or equal to 4, rather than saying 4 is less than or equal to x. They're equivalent statements, but it just makes more sense to write x in front first. And of course, the graph is the same. If you're saying that 4 is less than or equal to x, and do you see why it makes more sense to write it this way? Because if you write it this way, the interpretation is all the x values are greater than or equal to 4. So it makes sense, hey, draw everything above 4 and include 4 from this uh, expression. But when you look at it from this perspective, it makes a little bit like less sense as to how to graph it. 4 is less than or equal to x. So then you're like, yeah, I understand 4 is less than. So then still, what are the x values? They're everything above 4. That's why we write it this way instead. So of course, if the solution is the same, the graph is the same. So, okay. We good with that? Okay, good. Next, let's get into some more interesting ones. How about something like this? 6 minus 2, x minus 4 is less than or equal to 2x plus 10. So now we have more stuff to take care of. So I can distribute the negative 2 and I get 6 minus 2x plus 8 is less than or equal to 2x plus 10. So now you have the decision. You can make all the x's on the left side or all the x's on the right side. I prefer moving all the x's on the left side first. That's what I prefer to do. So then I can combine like terms here and I get negative 2x plus 14 is less than 2x plus 10. Subtract by 2x, subtract by 2x. And I get negative 2x minus 2x is negative 4x plus 14 is less than or equal to 10. Subtract by 14, subtract by 14. And I get negative 4x is less than or equal to negative 4. Divide by negative 4, divide by negative 4. Remember, when you divide by a negative number in an inequality, you flip the sign, and this becomes positive 1. So x is greater than or equal to positive 1. Now, what would be the graph of this solution? Well, I'm just saying x is bigger than 1 or equal to 1. So then I would say 1, close circle, shaded to the right. What would be the interval notation? The interval notation would be everything from 1 included to positive infinity. Are we good so far? Any questions about solving linear inequalities, finding what x is, graphing it, interval notation? Is everything all right with this?
I have a question actually.
Yes.
This might seem a little elementary, but I'm confused with like like for the 2x you minus 2x, but like for the negative 4x you divided negative 4. So how do you know when to just like minus or or add it, like to cancel it out or divide it? I don't know, but I'm confused about that.
That's fine. So you're asking why is it that I subtracted 2x and then why is it that I divide by negative 4? When do I know when to subtract or when to divide? Like, when do I know how to do that? So the name of the game, so there's like a little game, right? I want to get x on one side of the inequality or equation for these kind of problems, right? I just want to get x alone. That's the goal of this game. The problem is I got x's on two sides of the inequality, or I can have two sides of the equation. I have x's on both sides. So the first order of business is to get all the x's on the same side. The only way to make all the x's on the same side is to either subtract or add, not divide. I can't move. So this is like a move, right? This is like a step. I can't physically move the x's by dividing, but I can move them by subtracting. In this case, I got negative 2x on the left side and positive 2x on the right side. So I want to get this x guy over here. I want to move it over here. I want to move it physically in a way. And the way this works in mathematics is if I want to move this guy on the right side to the left, I have to do the inverse operation. So if there was a positive 2x here, I have to subtract by 2x. So that what? Why do I subtract? Because if I subtract 2x on the right side, 2x minus 2x is 0x, 0. It goes away. It disappears. And that's what I want. I want it to disappear from the right. I want the x's to disappear on the right side. But in order to do that, by subtracting it on the right side, to keep the inequality the same, I also have to subtract on the left side. And so then I've accomplished my little sub goal, which is to get all the x's on the same side. And then I want to move this guy on the other side. So I must subtract by 14. That's why I subtract. I don't divide. Now, when I get to this particular point, though, negative 4x less than or equal to negative 4, remember, the goal of the game is still to get x by itself. The problem is I have this negative 4 attached to the x by multiplication. So I got negative 4 times x is less than or equal to negative 4. And the name of the game is what? Get x alone. I don't want the negative 4 next to it. So what I have to do is apply the inverse operation, which is just saying, I need to apply the opposite operation that currently is seen here. I have a multiplication that's being applied to negative 4 and x. So to undo multiplication, I need to divide by negative 4. Because what happens when I divide by negative 4? What is negative 4 divided by negative 4? It's 1. And then I achieve my goal in getting 1x less than or equal to positive 1. And of course, I have to switch the sign because I divided by a negative number. Does that make sense?
Yeah, thank you.
No problem. So that's perfectly fine if you ask any kind of question. I hope I get to clarify it. So if that makes sense, great. Any other questions about this? So again, you can treat inequalities very similar to just regular equations that we've done. But the difference is that at the end, it's not just one value for x, it's an interval that we're shading here in this particular case, and that we have to represent as an interval. Okay? Okay. So I heard somebody talk about fractions that they need some help with. So let's figure out how to solve now. What happens in this case when I have fractions in my inequality? Am I gonna get scared and run away? No. I'm gonna do the same exact thing. I want to get all the, so see, the goal of the game has not changed. I want to get the x alone. The first order of business, though, is to get all the x's together. So to get all the x's on the same side of the inequality, I need to either decide whether I want all the x variables to be on the left of the side of the inequality, or if I want all the x variables to be on the right side of an inequality. Of course, I'm going to decide to choose all the left side for the x's. So then I'm going to have to add, because I have subtraction here, right? I have a minus 1/3 x, so I need to do the opposite operation, which is to add. So I need to add on both sides. And again, I'm only going to line them up underneath their common or their like terms, because it doesn't make sense for me to add 1/3 x to a fraction that has no x next to it. I can only add it to the things that are the same kind. So for those expressions here that have an x in front of them, I'm going to add all of them together. So these cancel, they become nothing, 0x, and this becomes less than 7/6. I haven't touched that yet. This is negative 3/2, and 2/3 x plus 1/3 x is how many x's? It's 1x, right? It's one single x, so I can just write one single x, and look at this, not too bad. And now I can add both sides by 3/2. Add both sides by 3/2. And I get that x is less than or equal to 7/6, pardon me, 7/6 plus 3/2. So then how do we add fractions again? 7/6 plus 3/2. I need to have the same denominator, of course. What's the LCD between 2 and 6, or the least common multiple between 2 and 6? It's going to be 6. So that means that the 7/6 I can leave alone. I can let that be. And I'm going to multiply top and bottom by 3 here. And I get 7/6 plus 9/6. That's a total of 16/6. But then you can simplify 16/6 by dividing the top and the bottom by a common factor, which is 2. So if I divide both sides here, the top and the bottom by 2, I get 8/3. So x is less than a fraction, 8/3. And then the graph of this is going to be, the graph of the solution on the number line is going to be 8/3, open circle, shade to the left. And then the interval notation will be everything from -infinity all the way to 8/3, excluding 8/3. And that would be my final solution here. All right. Good.
I have a question.
Yes.
Did you divide the 16 by 2 just to simplify it more?
Correct.
Okay.
Yes. So whenever we get fractions, we always want to see at the end, if we can simplify it. Of course, in this context, right, we don't want to simplify. We want to have the same denominator. So therefore, I multiplied this fraction by 3/3. So I can have the same denominators, in which I was able to combine them as a single fraction. And then as I have it as a single fraction, then I can see if there's anything in common. If there is, then you can divide it by that common factor, which gives you the simplified answer. So David, multiplying fractions, like we discussed last time, multiplying fractions, so this is just really quick. So if I want to like do this, right, 3/5 times 7 over, like something like this, 7/5. If I want to multiply fractions, I multiply the numbers across. That's it. This is 21/25. That's how easy it is. And sometimes though, for example, if I do this, 3/5 times 25/9, sometimes I can multiply across, right? But if I have common factors such as 3 and 9 and 25 and 5, I can actually cancel. I can cross cancel in a way, or cross simplify. This becomes 5, this becomes 3, and then when you multiply, you get 5/3. You see that? So multiplying is pretty straightforward. If I were to divide though, if I do like 7/21, no, sorry, 7/16 divided by 8/21, for example, remember you keep, change, and you flip. So this is 7/16 multiplied by 8/21. And then look what I could do. I can cancel out the common factors. Here, from 8 and 16, I can divide both by 8, and I get 1 and 2 on the bottom. 7 goes into 21 3 times. So then the result, I still have to multiply the numbers across. Do you see that? 1 times 1 is 1. 2 times 3 is 6. So the answer would be 1/6. Okay? Does that make sense? So like we talked about this in the previous lectures. All right. So we're good with the solving inequalities. Now I want to direct my attention to solving compound inequalities. So this word compound immediately indicates that there's more than one. Same thing. Yeah. So when we have compound inequalities, we have more than one inequality. So essentially, we're only going to be solving two inequalities at once. So for example, if I have this compound inequality, 1/3 x is less than -1, or 2x is greater than 0. So here I'm going to have two inequalities that I'm solving simultaneously in a way, or one after the other. So here I want to get x by itself. That has not changed, but I'm doing it for two inequalities that's paired up together. So let's look at the right inequality because that's kind of quick to do. So if I want to get x by itself, divide both sides by 2 because I have that 2 attached to it by multiplication. So I divide by 2 and I get x is greater than what? 0, because 0 divided by anything is 0. Okay? And then on the left inequality, I multiply everything by 3. So I get that x is less than or equal to -3. So x is less than -3 and x is greater than 0. So let me graph this. Now the graph is going to be an extension of what we've been doing so far. So when we graph, I got 0 and I got -3 to worry about. Since you didn't, okay, so I don't know if I'm saying this name right, Nargis or Nargis. Since you divided, don't you have to switch the sign, Professor? Remember what the note is, right? So be careful. This is very specific. The note is when you divide or multiply by a, maybe I should emphasize. If it's a negative number, then you flip. But if you just divide a positive number, you don't flip. You keep it the same. So when I divide it by +2, I don't flip the sign. I leave it as greater than. And so you can only multiply by 3 when the numerator is 1. No, I multiply by 3 because I want to get rid of the third. So whenever, for example, if I do like let's do 1/5 x is less than or equal to 4, for example, right? I want to get x by itself. So what do? I multiply by the reciprocal. So then that's what I'm going to get at. So if this was a 2, right? Very good question. If this is a 2, what would be the difference? I'm going to multiply by the reciprocal. I multiply by the reciprocal of the fraction. Why? Because when I multiply by the reciprocal, a fraction plus times its reciprocal will always equal 1. 2 times 5 is 10. 2 times 5 times 2 is 10. 10 divided by 10, 1. Remember, the name of the game is what? Getting x, a single x. So in whichever way I'm able to do that, I'm going to do that. So the technique is that when you have a fraction in front of the variable, you make that fraction into a 1 by multiplying by the reciprocal. That's like the step for that. So that's why in this particular example, I multiplied by 3 because the reciprocal of a third is 3/1, which is just 3. That's why. Okay. So now I shape.
You don't
Say that again.
Like you don't.
Pardon me?
Like the flipping the sign, like greater or equal.
What about it?
So you don't flip the sign in that case?
In which case? In this one or in this one?
No, the other one. No, the other one.
This one.
No, all the way to more.
This one.
Yeah.
Yeah. So these you don't flip the sign. You only flip the sign if this were a negative.
Oh, okay. So
if it's a positive, leave it. The same thing happens here, right? I divided by 2, positive. I left it. If I multiply by 3, the less than symbol remain the less than symbol.
Oh, okay. All right. So only when it is negative, then you flip the sign.
Correct.
Okay, gotcha.
Correct. Yep. So then now I'm gonna graph both of these. I'm gonna graph both of them because the key word here is or. So it says x is greater than 0. So I'm gonna shade it to the right of 0. Or it's x is less than -3. Shade it to less than -3. So that's the graph. Now I have two intervals. And then when I want to write the interval notation for this, if I want to write the interval notation for this, this would be -infinity to -3. Now, how do we describe or, the English word for or, how do we describe that in using set notation? We use the union symbol. Whenever you see the union symbol, this really means or. So union, so let's make that a note. Note, the union symbol means or. So that what we're saying is the interval notation is -infinity to -3 or 0 to infinity. Okay. So that's how we're going to approach these inequalities now. Now, we have other kinds of inequalities, compound inequalities, that instead of having the or word in between them, we have something that has the and. Very good, Elizabeth. Yep. So we have or for inequalities, compound inequalities, or and. So when we solve them, we're still going to do the same thing. We're going to treat them individually and solve it, but then we're going to have to do something different for the and portion of it. So if I divide by 2, in this example here, I get x is greater than or equal to 3. That's 1 inequality solved. And the other inequality solved is I subtract by 4 on both sides, and I get that x is greater than or equal to 1. And what I'm going to do is I'm still doing the same exact thing. I'm going to graph both of them. So I have 1 and I have 3. For x greater than or equal to 3, I'm going to shade because I'm including 3. And I am shading it to the right. And for this guy, I'm going to also shade in the 1 because it's equal to 1. And I'm shading it to the right as well. But what's the difference? I'm saying and. And indicates, so note, the intersection symbol that means and. So what I'm asking for is what is the intersection between x greater than or equal to 1 and x greater than or equal to 3? What is the intersection? That's why it's helpful to graph this, because then you start to realize, where do I intersect? Where are both of the shaded regions overlapping? So Jalen, the overlapping portion is where you shade on both, for both areas, right? For both regions or intervals. So for example, here, I only have the blue shaded. I don't have the blue and the pink shaded. So this is not the overlapping region. This is the region that only applies for this guy here. So actually it's everything from 3 to infinity. Remember, it's the overlapping region that I care about. It's not the non-overlapping region. So and indicates intersection. Intersection is where are both of them shaded as well. So the overlapping region is actually, so I'm gonna use this. This would be the answer here. So that would be the graph, 3 to infinity. That's right. And so then when you write the interval notation for it, you have 3 included to infinity. Do you see that? Now, when we have this and scenario, you could have also looked at it. Well, I'll give you another example. So this is how we do this one. Any questions about these two kinds of problems where we have an or inequality or an and inequality?
I have a question.
Yes.
For the second example, why isn't 1 included into the interval notation?
Okay. So it's because the reason why it's because of the word and. So then the question would be, well, what if it wasn't and? What if it was or? Do you see how it would be different? So let's make that the case. What if I have the same inequalities, the same ones, the exact same ones, but instead of having the and in between, I have an or. What would change? Well, not much in terms of the answer for each inequality. I would still get the same answer because it's the same exact inequality, right? The only difference that it will make is that when I do graph it, I'm still gonna do this, right? 3 and 1, right? I'm gonna shade everything from 3 to infinity. I'm gonna shade everything from 1 to infinity. But the difference is I'm gonna interpret this with the or mentality. I'm gonna say include both. Union both of them. So remember, with the union, you include everything. So the union of being bigger than 1 and being bigger than 3, the union of that set is everything 1 and above. So the interval notation for this one would be the one that you're talking about. The result would be 1 to infinity. Why? Because I'm including both. And it just so happens that this guy is within this set here. It's within it. So I'm including both of them.
Okay, I got it now. I got it.
Yeah. So I guess maybe, yeah, it's really just the way you interpret it, right? It's let's see if I can. Because like if you visualize it as sets, right? If I say A and I call this B, right? And I say shade in A intersect B and shade in A union B. They're two different things. If I say A union B, I'm saying include A and include B all together. So that's when I would shade the entire thing, which is exactly what I'm doing here. I'm taking the entire thing because this is the or. This is also known as A or B. But if I do A and B, I'm taking the intersection of both of them, which will only include this B portion. I don't know if that helped, but if it didn't, don't worry about it. But if you understand what I just said with these shaded regions, then that's okay.
I understood it. Thank you.
Okay. Okay. All right, good, good. So now let's continue with this whole with the inequalities. I want to finish soon because we have the quiz in like a few minutes, in 10 minutes. Now, what if I have scenarios that look like this? So this, guys, this is also an inequality. It's also compound. Why? Because I have two inequalities at once. But instead of it being written like the ones we had before, where we have the or the and, right? We specifically have two different inequalities being written out. We're having kind of one compounded at once, but there's also two of them at the same time. So instead of saying this, 3x plus 4 less than 16 and 3x plus 4 greater than negative 5, instead of having this being rewritten twice, I just write it in one single line. And what's beneficial from this is that solving this is actually solving these two inequalities that are written in one line. We can do it in one single swoop, like in one single stroke. So we can subtract, for example, at the end of the day, I still want to solve for x, right? I still want to get x by itself. So what would I do first? I would subtract 4, right? But now I can subtract 4 on the inequality. If I'm subtracting 4 from the inside here, I'm also going to subtract on the right of the inequality. I'm also going to subtract 4 from the left side of the inequality. So I'm left with 3x is less than positive 12 greater than negative 9. And then what am I supposed to do to get rid of the x? I mean, to get x by itself, to get rid of the 3. I need to divide everything by 3. So then what do I get? I get x is less than 4 and x is bigger than negative 3. And so then graphing this inequality here, it's pretty straightforward now, isn't it? X is between negative 3 and 4. So negative 3, negative 4, positive 4, pardon me. Positive 4. I'm going to shade 4. No, actually, I'm not going to shade 4. I'm going to open circle 4, open circle 3, and shade everything in between. So that would be the graph of this. And then what would be the interval notation? It would be negative 3, positive 4, and open parentheses for both. Okay, does that make sense? And solving inequalities like this, you're literally just applying the operations all at once. All right. Okay, so then this all boils down to dealing with what are called absolute value inequalities. So this is when things get a little bit interesting. So first of all, does anybody remember what absolute values are? Oh, Amelie, how do you know when to put the brackets and parentheses? You know by looking at the inequality symbols. So if the inequality symbols at the end are strictly less than, without the bar underneath, then it's open circle. So that's why I know. That's how I know. This indicates open circle. And then this indicates open circle. Can you explain the graph? The graph for this, well, x, so if it's a closed circle, it's a bracket. Yes, yes, yes. So if it's less than 4, right? Open circle. If it's greater than negative 3, open circle. Open circle, parentheses, parentheses. Now the graph of this, x is between, x is less than 4, and at the same time, x is bigger than negative 3. So therefore, I shade in between. That's why I shade in between, because you can think of x being kind of the solution is anything between negative 3 and positive 4. So I'm shading everything between negative 3 and positive 4, but I am not including negative 3 or 4 because of these inequality symbols. Okay. I hope that clears it up. So now we're going to talk about absolute value. And absolute value, as someone has mentioned earlier, is the distance between a number to 0. So for example, if I were to say 5, the absolute value of 5 is 5. The absolute value of -5 is also 5, because when you look at the number line, distance is always positive, or I should say is always non-negative. We can never say, hey, that's -5 feet away. We can't say that. We always talk about distance in a positive sense or in a non-negative sense. So it could equal 0, but it can't be negative. So if I want to find the absolute value of 5, I want to ask what's the distance from 5 to 0 on the number line? Well, it's actually 5 units, right? I went 5 units to the right. But if I consider the same problem, what's the distance from -5 to 0? Well, how far away is -5 to 0? It's 5 units to the left of it. But so the distance is still 5. So therefore, the absolute value of -5 is 5. But now the question becomes, what happens, for example, when I say the absolute value of x? What if I say this is less than 5? What am I saying here? So what I'm saying here is that the distance from 5, the distance of x to 0 has to be less than 5 units away. So that's what it means. So the distance of x to 0 is less than 5. In other words, what x values have a distance to 0 that's less than 5 units? Well, wouldn't it be everything in between -5 and 5? Every point in this interval, the distance is to 0 is less than 5. And you exclude -5 and 5, right? Because 5, the distance of 5 from 0 is equal to 5. It's not less than 5. That's why we exclude it. So in other words, guys, this has another representation. The absolute value of x less than 5 is equivalent to saying that x is between 5 and -5. You guys see that? So then that means that, for example, if I do x is less than 10, the equivalent compound inequality would be x is between 10 and -10. Let me see something. Okay, so we'll start the quiz in like 5 minutes from now, okay? Not 11:45, around 11:50. Okay, so then let me just finish this real quick and then we'll be done. So does everybody see that relationship? So if I do the absolute value, for example, of less than another number, I'm gonna call this a though, a variable, then the equivalent compound inequality would be x is less than a, but less than -a. So that's the general relationship. So replace this a value with any number, positive number, then you would always have this equivalent compound inequality. So this absolute value inequality can be represented as a compound inequality. So that's the name of the game here. And for example, if I have something like this, x plus 10 is less than 8, for example, what would be the corresponding compound inequality? How do you think this would look? Knowing this. So what would be the compound inequality for this? Well, treat this as one single thing, as another variable. And what's the absolute value of a variable less than a number? Well, then we can represent this as x plus 10 is less than 8, but bigger than negative 8. And then can I further solve the compound inequality? I've done it already, right? We've already talked about solving a compound inequality such as this. So I want to get x by itself. So then what is x by itself? Subtract by 10, subtract by 10. And I get x by itself is less than negative 2, but greater than negative 18. And then this would be, the graph of this would be everything from negative 18 to negative 2. Because I have open circles here, these inequality symbols, then the open circles will exist on the graph, and I'll shade everything in between. And then the interval notation would be negative 18 to negative 2. Okay. So now we know how to solve inequalities, linear inequalities, compound inequalities, and absolute value inequalities, because you just transform the absolute value inequality into a compound one. So any questions about this? If no questions, then I'll